Nanotechnology is the ability to understand, control, and manipulate matter at the level of individual atoms and molecules. And we need to use and understand nanotechnology to create materials, devices, and systems with fundamentally new properties and functions because of their small structure. And likewise, we can employ these atomic and molecular interactions to develop efficient manufacturing methods. And while this definition was agreed upon by the National Science Foundation and National Nanotechnology Initiative a few years ago, we've certainly been dealing with atoms and molecules for a long time. In fact, stained glass windows in a famous cathedral in Milan have their color because the people who made them exploited the unique size-dependent properties, colors of gold particles to create the beautiful windows that we see today. And over 100 years ago, researchers were making carbon filaments, much as carbon nanotubes are made today, and remarked in their patent application on their outstanding strength, flexibility, and properties. But really what nanotechnology and nanoengineering is, and why we are at a forefront today, is because we have the tools and insights to be able to measure, watch, and understand these unique properties, and to engineer materials and devices that take advantage of these unique effects. And for example, some recent discoveries of the past 20 years have been the revelation about the structure of carbon nanotubes done by Ajima in 1991, and the pioneering demonstration of the unique properties of a ring of individual iron atoms that was done by placing these individual atoms with atomic precision using a scanning tunneling microscope in 1993. More recently, scientists have shown that, believe it or not, individual molecules can behave in some ways like macroscopic components, like a rack and pinion gears that we can touch with our hands only at the molecular scale. And at the top left, we see a picture from a publication from 2 years ago where it was shown that a single molecule with 6 N groups, as shown here, can roll along a textured surface much like a pinion rolls along a rack. And this year it was shown that DNA strands can be controlled such that they assemble into these intricate polyhedra. In this case, we have an icosahedron where the diameter of it is tens of nanometers, which is thousands of times smaller than a human hair. And although we are very early in these fields in general, there are already a lot of interesting and important commercial applications of nanomaterials and nanotechnology. For example, those size-dependent properties of nanoparticles, like we saw in the stained glass windows from centuries ago, can be used for making efficient solar cells, and in this case, the semiconductor particles are referred to as quantum dots. Also, there has been work in creating memory, high-density memory, that can operate in harsh environments using individual carbon nanotubes. Here, where the crossbar structure shown in the figure represents an individual bit. So the movement of one carbon nanotube up and down upon the other can be a non-volatile memory that lasts for billions of cycles. Likewise, there are a lot of applications of nanotechnology in drug delivery and bioimaging, particularly if we are able to control how materials are built at the atomic scale and understand how they interact with elements in our body. Biology is itself an amazing example of nanotechnology. We could see a lot of fascinating and important applications in drug delivery, imaging, and other medical areas. There have also been innovations in nanotechnology leading to high-power nanostructured batteries. For example, use of nanostructured lithium particles in batteries by the company A123 Systems has led to a line of new power tools, as well as a lot of innovative battery designs that will be seen on the market soon for hybrid electric vehicles. And there have also been applications, believe it or not, in sports equipment. Nanocomposites are used, for example, to increase the vibration resistance of baseball bats, tennis rackets, and golf clubs. And with all these commercial applications comes the opportunity for economic growth. And there are many studies that show that nanotechnology will have a significant economic impact in the coming years. For example, this table shows that spanning from the materials, electronics, pharmaceuticals, and healthcare industry, nanotechnology in general will have hundreds of billions of dollars of impact approximately in the future time frame. And these numbers are not specific and exact, but certainly it can be said that engineering and controlling material at the atomic scale will be impactful. And it will be so important that many standards organizations, including ISO and IEEE, are actively developing standards for understanding and controlling the use of nanostructures such as carbon nanotubes and quantum dots in processing and in large-scale manufacturing.